With the idea of mutual exclusivity or disjointness in mind, we can build towards one of our first big concepts for taking multiple probabilities into account, called the addition rule, where if we have disjoint events A and B, the probability of A occurring or B occurring, understand that when we're talking about this, we don't mean that they happen one after the other, or we're looking for both occurring. We're just saying, give me one or the other. We're doing one thing. If they are disjoint, we just add their respective probabilities up. For example, if I flip a coin, there's no way that I can get both tails and heads at the same time. So those two events would be disjoint. And if I want to get the probability of tails or heads, A or B, it would be the probability of tails, 1/2, plus the probability of heads, also 1/2, for a total of 1. And this kind of hints at something important, that when we're talking about mutually exclusive or disjoint events, complementary events are a great example generally, because you cannot have both the thing happening and the opposite of it happening at the same time. Something would be very, very much wrong if that were to occur. So, with those cases, the total probability A plus B follows that rule we saw earlier, although that's not every single case we'll get, as we'll see later. On the other hand, if we look at events that are not disjoint, if we look at events that can happen simultaneously, then we have a little bit more to consider. In those cases, we have to think about the fact that we have the probability of A plus the probability of B, and then minus the probability of both. And hopefully looking at that triggers some memories going all the way back to chapter 2 when we were talking about sets, because this was the same way that we talked about sets. We were looking at the cardinality of unions. A sum of probabilities is a lot like looking at a union there, where if we have an event and another event with overlap, when we count the probability for this one, we'll get a little bit of both. When we count the probability for that one, we'll get that same chunk of both. So we need to avoid double counting and knock out that little bit extra in the middle. So for example, if we're talking instead about rolling a die like before, and we want to talk about getting the probability of a 3 or any other odd number on the die, we must understand there that when we're getting the probability of rolling a 3, so P of 3 or odd, we have one case out of 6 which will count the 3, but then when we get the odds, we will have 1, 5, and 3 again. 3 out of 6. So here we got 3, there we got 3, we got too many 3, take out 1, and what we'll end up with is 3 out of 6, or 1/2 for that total probability.